Okay, so this is a lesson on our second day with modeling with exponential and logarithmic functions. What I would like you to do is to please pause the video and work on these 7 warm-up questions. Okay, you should be done with the warm-up now. Pause it and work a little more if you need time. Here are the answers to these warm-up questions. I want to take a look at just 2 of them. Any others you can see me at lunch tomorrow. So here we go. First off, I just want to make sure everyone really understands how to do ones like 1 and 2. So I'm just going to plug in number 2 because it's less writing. So for number 2, we would do 2e, and then x becomes natural log of 12. So we do ln 12. And we want to know, does that equal 9? Well, right here, e raised to ln 12, because these bases match, it becomes 2 times just 12. Well, 2 times 12 is not equal to 9, so we say it is not a solution. The second one I want to take a look at is number 7. It says find the exponential model that passes through 1, 2, and 4, 54. Well, to get from 1, 2 to 4, 54, I'm thinking to myself, all right, 1, 2, 3, 4, 2, 54, and it takes 1, 2, 3 times whatever b is. So I write the equation, oops, that's kind of messy, 2b cubed equals 54. Because if I multiply 2 times 3 additional b's, I'll get 54. And now I'm just going to solve this equation. So I'm going to divide by 2 and get 27. And then take the cube root, or just think to myself, what cube gives me 27? And b is 3. And then to find my a value, I'm just going to back up to 0, and 2 divided by 3 is just 2/3, and that's where I get this equation. And again, anything else, you can see me at lunch tomorrow. Here are the answers to last night's homework. I just want to look at one question that I think people might have been a little tricked out on because the fraction's number 23. All right. So for number 23, again, you want to think to yourself, to get from, where are those numbers again? To get from 4 to to get from -1 to 4, it would take how many b's? Well, it would take 5. So we're going to write the equation 21 over 2, b to the 5th, equals 112 over 81. Okay, so now I'm going to multiply both sides by 2 over 21. And when I do that, I'm going to get b to the 5th equals 32 over 243. And honestly, guys, you just got to break down the 112 and stuff starts to cancel out. All right, so now when I see this, what to the 5th power gives me 32? Well, that's 2. And what to the 5th power gives me 243? That's 3, so that is my b value. And again, we're just going to we can multiply then. We've got, because we know that -1 gives us 21 over 2. If we take 21 over 2 and multiply it times 2 over 3, we get 21 divided by 3, which is just 7. So that gives us y equals 7 times 2/3 to the x. All right. What I want everyone to do is pause the video and find the page in your packet that looks just like this. All right. What today's lesson is just a summary of these 3 types of functions and how we are going to recognize it. So the way we recognize an exponential function is that the y values have a multiplication pattern. Now, I'm not going to write a division pattern because at this point in our math careers, we know that every multiplication pattern can be written, every division pattern can be written as a multiplication pattern. Like if the pattern is divide by 2, it's really just multiplying by 1/2. All right. Logarithmic functions are the inverse of exponential functions. So their x values have a multiplication pattern. linear functions have an addition-subtraction pattern. And last but not least, we have quadratic functions, and the only way to prove a table of values is a quadratic function is to take the second differences with two sets of finite differences. If you remember, we did those at the end of first semester. That's when you subtract the y values from each other, and then after two sets of subtraction, you get the same number over and over again. So yield a constant. Okay, so it says practice. Which model best fits the function, write the function, and evaluate for the given value of x. So here we go. Now, number one, when I look at these y values, I can see it's 3, 9, 27, 81, and immediately I see that the model is exponential. I want to make this font smaller so it fits. There we go. The function, it's pretty basic because I see it's multiplying by 3 each time. What I do need to do, though, is kind of back up the pattern to 0. And if I do that, I can kind of see, well, if it's multiplying by 3, if I divide by 3, I'm going to have 1. So the function is going to be y equals 1 times 3 to the x. And then f of 7 is just going to be 3 to the 7th, which is 2,187. All right. So when we look at number 2, we look at the pattern, and it's 3, 6, 9, 12, 15. Immediately we should notice that the pattern is add by 3. So the model is linear. Oop, that's an A. The function is y equals 3x. Okay, and now we need the y-intercept, so we're going to back up the pattern. And 3 minus 3 would just be 0. So y equals 3x is fine. And then f of 9 is just going to be 3 times 9 is 27. All right, here we go. Number 3. Here I look at my y values, and I've got 1/2, 1/4, 1/8, 1/16, and I can immediately see it's a multiplication pattern of 1/2 each time, so the model is exponential. The function is going to be y equals, and again, if I back up the pattern and divide by 1/2, I get 1. So 1 times 1/2 to the x. And then I'm going to plug in 8. Oops. I'm going to plug in 8 for, I'm going to plug in 8 for x. Well, 1 to the 8th is just 8. And 2 to the 8th is 256. So my answer for f of 8 is 1 over 256. Right, when you look at number 4, hopefully you notice a pattern here. Now, I could do the second differences, or I could have like just a moment to be like, hey, guess what? 1 squared is 1, and 2 squared is 4, and 3 squared is 9, and so guess what? It is quadratic. And honestly, guys, I'm not so worried about this one because we studied quadratic functions first semester, and that is not our focus today. So it's just x squared, and f of 10 is 100. All right, now where is our focus today? Here is our focus today. Take a look at these guys. I see that my x values are a multiplication pattern, and the y values just increase by 1. And because of that, this tells me I have the inverse of an exponential. I have a log function. And because the multiplication pattern on the x's is by 4, that tells me that my model is going to be y equals log base 4 of x. Now, log base 4 of 4,096. So this is going to take a little bit of time, but it's kind of nice because I already have up to 5 here, and if I just multiply this by one more 4, hey, guess what? There is my 4,096, so the answer must be 6. All right, take a second and try 6 and 7 by yourself. Pause the video. Okay. When you look at number 6, you should immediately notice that the pattern here is multiplying by 2. So that makes the model exponential. The function is going to be y equals. Now, again, I don't have the 0, so I just back up the pattern. If the pattern is multiplied by 2, divide by 2, and we get 5. So it's going to be 5 times 2 to the x. F of 10, well, 5 times 2 to the 10th. Might want to input a calculator for this or some extremely good arithmetic. But you are going to get 5,120. Number 7, immediately I notice my x values have a multiplication pattern of 5, so the model must be a log function. And we've got y equals log base 5 of x. Stupid 5s. And again, it's very convenient that it just happens to be the next number. Otherwise, I would have to do some really serious factoring with this. So log base 5 of 15,625 is going to be 6. Okay. Number 8, I want everyone to try number 8 and number 9. No, actually, check that. Don't try number 8 and number 9. Just take a look at the patterns for a second. What do you notice about the x values in number 8 and the y values in number 9? Yeah, the difference here is that the x values in number 8 are adding by 2, and the y values in number 9 are adding by 2. But when I look at the other values, they are kind of following those more traditional patterns we saw in the others. This is still just a multiplication pattern. And this one is also just a multiplication pattern. So how are we going to handle that? We can't just interpret this as exponential with a b value of 4. So we have to think to ourselves, all right, well, we know that this is exponential. But what's the function going to be? Well, this is where we have to get a little creative and say to ourselves, all right, well, if this is 2 and this is 4, in the middle here is 3. And if we're multiplying by 4, what are we multiplying by in between? Well, 12 times 2 would give us 24, times another 2 would give us 48. So I know my b value is actually 2. Another way to look at this is to say 12b squared equals 48, like we did yesterday, and solve, and you would get a b value, because it would be b squared equals, well, 48 divided by 12 would be 4, and then b equals 2. Not plus or minus 2 because it's a pattern. I think I spelled exponential wrong. I did. I lost an N. All right, so back up the pattern. So divide by 2, and we would get 1, 6. Divide by 2 again, and we've got y equals 3 times 2 to the x. And then 3 times 2 to the 11th would just be 6,144. Number 9, we still have to deal with this whole adding by 2 phase. So now we've got a b up here. So, we kind of think about here the multiplication pattern is 2 times b squared equals 4. So, unfortunately, now we've got b squared equals 2, and b is equal to root 2, which is just a little weird, but it's not the end of the world. It's still a log function. It's going to be y equals log base root 2 of x. And again, I just want to point out, we found the base the same way we would have yesterday, and the same way we did up here, by calculating, okay, 2 steps to get from here to here, and I'm noticing what the pattern is. So, log base root 2 of 64, my best suggestion is continue the pattern. If I multiply 16 by 4, okay, I just noticed like a humongous mistake that you guys probably noticed like a long time ago. This is not multiplying by 4. This was multiplying by 2, which I kind of did here, but I don't know. Sorry, I had a dumb moment. So if I can just continue this pattern, which is multiplying by 2 every 2 steps, 16 times 2 would give me 32. And then that would be when f of x is 10, and then multiply by 2 again, and that would give me 64 when it's 12. And I apologize for that mistake, and I'm sure a lot of you noticed it way ahead of time. So log base root 2 of x is 12. All right, we've got 2 problems left, and for these 2 problems, we are going to use our calculator. So this is nothing new. We are just going to type these in because it says to use the exponential regression feature. So what I want everyone to do is to turn on your calculator and go to Stat Edit. This goes in L1. This goes in L2. And go to Stat, Calc, and then it's all the way down at the bottom. It's number 0, xbreg. So go ahead, pause the video, and put that into your calculator and find out what the equation is. Okay, so hopefully you've had time to do 11 or 10 and 11, and you can see I have filled in the equations that I got from my graphing calculator. And I want to just point out for the part B is this is really just straight on the home screen, typing it in, finding out how many bacteria there were. I rounded to the nearest whole bacteria because I felt that was an appropriate way to round. For number 11, because it starts with 1970, 1995 is 25 years since 1970, so I put 25 in there. And I rounded to 2 decimal places because it's money, and I felt that was appropriate. So there's one more question here that, again, and this one just wants you to use the exponential regression function on your calculator to come up with the model. And if you take the time to put that in, go ahead and do that right now, and I'll type it in, and we'll probably all get the same answer and be happy and start our homework. So there you go. If you're good with your homework, go ahead and start the video. Go ahead and stop the video, and you can get started. All the answers to the homework will be on Edline.